Okay, good afternoon. We're going to be looking at the second day of Chapter 9, Topic 7, Graphing Rational Functions. And we're only going to take a look at problem number 2, because problem number 1, we saw this types of problems in the first day. So we're going to take a look at, well, actually, no, we're just going to look at the third problem here. Because these two are exactly like the ones we saw in the previous day. So we're just going to take a look at the third problem. And the third problem has to do with if you want to see examples like numbers 1 and 2, you can find them on the day 1 lesson. So this one is a little bit different because it's not in the form of 1 over x minus h plus k because of this 2 in front of this x here, or sorry, a, because of this 2 in front of this x here. However, you can fix it so that you can put it in this form. And essentially what we're going to do is we're going to factor out that 2 from the x. So that means we have 2 over x plus 1. Now, it might not seem obvious at first, but you can think of this as 1/2 multiplied by 1 over x plus 1, which, if you think about it, is the same thing as a multiplied by 1 over x minus h. So what we see here is that our a value is actually 1/2. And that's going to help us out with understanding. Putting it in this form is going to help us graph it because we can recognize the transformations. So we can see when we put it in this form and we factor out the 2 that our a value is 1/2, our h value is -1, and our k value is 0. So now I can use this to graph it, and that's really all I needed to do with the form is change the form, but now I have all the information I need, so I can set everything up and just use the original equation to graph it. Vertical asymptote, x equals h, so x equals -1. Horizontal asymptote, y equals k, so y equals 0. I'll build my table around my vertical asymptote here, so let me go ahead and put it on my graph. It's at -1. And the other one's at 0 here. All right, so 0, whoops, nope, that's not to the left, that's to the right. So 0, 1, 2, to the left, -2, -3, and -4. I can plug each of these in to this equation right here. So plugging in -4 is 1 over -6. I don't know what that is. -1/6, whatever that is. So -0.16 repeating. Plug in -3, that's 1 over -4, so that's -0.25. Plug in -2, that's 1 over -2, so that's -0.5. Can't plug in -1. Plug in 0, 1 over 2, so that's 0.5. Plug in 1, 1 over 4, that's 0.25. And plug in 2, that's 1 over 6, so 0.16 repeating. Now you might, you'll notice that all of these points are like very, very close to the asymptote here. And that's because this a value is actually causing it to vertically compress by a factor of 1/2. So every point is half as close to the asymptote as it would be in the parent function. Like this one is usually at, what is it usually at? Oh yeah, it's usually at 1/3. It's usually at 1/3. And this one is usually at 1/2, and this one's usually at 1. So everything's been basically just cut in half, which causes it to vertically compress towards the x-axis, or the asymptote, by a factor of 1/2. So we can graph these points. We have this right here, and this right here. They're actually very hard to graph because they're so close to the asymptotes They're just very, very close to the asymptotes here. And same thing on the other side. Very, very close to the asymptotes, like almost indistinguishable, the difference between them. Whoops. However, we can still find the important information like the x and y intercept. So for the y-intercept, we can plug in 0. We already did that in our table. It's a half, and you can see that point is right here. It's our y-intercept. Our x-intercept we can find by setting the equation equal to 0. So we would have 0 is equal to, however, we don't need to do that, do we? I mean, we can tell that's where the asymptote is. The asymptote is on the x-axis, so there is no x-intercept. The domain, everything except for the asymptote, which is -1, and that's it. The range, everything except for the asymptote, which is 0. Whoops, y cannot be 0. All right, and this is how you graph and recognize a vertical compression. Typically, a vertical compression will be in the denominator because it's dividing it. It's cutting it in half in this case, or cutting it by a certain number, etc. All right, so that's the only thing we covered here in day 2. And that is it for this lesson.